Hi, Dr. Harris, back with part two of our second video for the first slideshow from chapter three in our data computing course. And we've been, in the previous video, we spent a lot of time looking at the basic outline of how we construct commands using ggplot. We set an aesthetic for the axes, and then we added a glyph. Mostly we were working with geom_point. And then we saw that inside the glyph call, we can add aesthetics to that. And then we can add on at the very end some labels to give some context to our graphic. And so what we want to do now is we want to explore a couple of other things that we can do with graphics in this video, in the second half of our slideshow. And so we're going to start off by talking about layering. And layering is simply we can think of it right now as the addition of more glyphs to our plot. So we're not restricted to having a single glyph in our graphics. And so what we are going to introduce for right now is a second glyph called geom_smooth. And so let's take a look at what the default rendering of a call to gm_smooth is. SE equals false. We'll be talking about SE more when we get to the regression portion of our course, right? But SE, it does stand for standard error. Basically, we're saying we don't want to have any error mapped around the glyph that we're going to be adding when we set it to false. So we're going to call geom_smooth. We're not going to have any wiggle around it, but we're going to attach the same aesthetic for color that we did to gm_point, which was to attach a color to the responses to sex. And so it'll use the same color scheme since we're not calling it anything. We didn't use anything but the default color scheme here. And so what we see gm_smooth adds, it adds a curve that tries to fit the data for each gender's response, or each set of gendered responses. And so the orangey reddish one corresponds to a curve that tries to fit the female data, and then the turquoise-ish curve is trying to fit the male's data here. And so we get these wiggly curves as it's sort of, again, it's confirmation in some ways that there's not much association as we read left to right between these variables. But speaking of association, we can actually draw lines. We can fit regression lines to these to the individual gendered responses as well, and that's by setting a value to the method inside geom_smooth. And so if I set method equals quote LM stands for linear model. We'll be dealing with linear models and regression much later in the course. But that's going to say, let's use a linear, find a linear regression line that fits the male's data and the female's data here. And we'll still set the color of those lines to be the same as the color for the data points that we plotted earlier. So when we set method to LM, we get regression lines. And so we get a slightly downward trending regression line for the women's values. As fastest speed increases, GPA tends to go down a little bit, but the men's line is almost flat. There's so much scatter around the men's responses that there's really no upward or downward trend that we can detect. And so the regression line running through the men's data points is almost flat. So that's a brief example of what we can do in terms of layering. We can add a second glyph to our plot. Now let's talk about faceting. I briefly chatted about faceting when we were going through the slideshow for chapter 2. And so what we want to recognize is that we're looking at the same variables, the same pair of variables in the horizontal and vertical direction, but we're going to be breaking it up by the values of some categorical variable. And so let's look at NHANES 18, that data set. It's in Tiger data. Let's look at the help file for it. NHANES stands for the National Health and Nutrition Examination Survey, and these were results from 2018. We see we had almost 10,000 individuals respond, and there was data collected on 18 variables. Let's see if I've got NHANES 18 here. So yeah, so we've got an ID, we have the respondent's gender, their age, their education level as part of 5 categories, their marital status, their income status, and then some various health readings, blood pressure, iron levels, cholesterol levels, and whether or not they have a few health conditions, asthma, arthritis, whether they've had a heart attack in the past or not. So let's look at the variables weight and systolic. We might think that weight has an impact on blood pressure. And so we're going to set up our aesthetic to be weight on the x-axis, y on systolic blood pressure on the y-axis. And if we just plot the points using geom_point, we get this. It's a big kind of blobby, but we do see an upward trend that heavier people tend to have higher systolic blood pressure. But there's a lot of uncertainty around that. There's a big cloudiness to this. So while there does seem to be a positive association, it's fairly weak in terms of being a linear association. But what I might want to do is I want to see, well, is there variation? Do we see variations on this plot if I break things up by education level? And so we can use the command facet_wrap to break our plot down by education level. And so the twiddle edu tells us that's the variable that we want to facet by education. N row equals 2 tells me I'm going to report back my results in 2 rows. And then the plus theme legend position equals top is just going to put the values of education at the top of each of my faceted plots. So let's see what the output to this is. I invite you to copy and paste this into RStudio just to see it yourself. But this is what we get. And so let's take a look at these legends. We have assoc, batch, high, under 12, under 9. So let's just briefly interpret these. Associates means that a person got the equivalent of an associate's degree, but did not finish getting a bachelor's degree. So they have between 2 and 4 years of college, and they did get something equivalent to an associate's degree. Batch means that they did receive a bachelor's degree or higher. High means that they graduated from high school but did not get any college degrees. Under 12 means that they made it past 9th grade but did not graduate from high school. And under 9 means that they did not even make it through 9th grade. NA means that there was no response for this variable. And so we see we have these 6 plots based on the 6 possible quote values of EDU, NA being quote a value. And what we see is that we have the same type of relationship in all cases. So education didn't seem to have any variation, didn't have any impact on the relationship between weight and systolic blood pressure. There seems to be a weak positive trend for you, no matter what education level you have. So, you tend to associate education possibly with wealth, possibly, but we're seeing here that it's not, at least initially, having any impact on the relationship between these 2 variables. If we wanted to get rid of the non-respondents to this question, we can do that using a filter command. Notice that we've got 2 uses of the pipe here. Filter is a command that we're going to spend a lot of time with in chapter 4. So, but this exclamation point means not. And so is.na edu means that we're going to filter out the not means there was no response to education. So we're going to filter that out. So it's going to remove all those data points. And so we have the pipe, we apply the filter to it that gets rid of all those rows in the data set that had no response for education, and then we pipe to that, from that filtered data set, the same command that we had before. And what that does is it gets rid of all the non-respondents to the education question. So again, I didn't do this to show any deep meaning to the results of faceting, but I did want to show you how we do facets. That's facet_wrap. So we'll play around with that when we get to class. And then finally, just want to point out that we've been having aesthetics defined inside our glyph calls, but we don't have to actually include all properties inside an aesthetic command inside a glyph call. So let's look at a couple of variations on that here. So we've seen this already, this graphic already, where we broke down color by different colors were assigned to the different responses for sex, and we had different sizes points depending on what the height response was. We're looking at fastest versus GPA out of the M111 survey data set. So we've already seen this. And in both cases, we had things mapped under an aesthetic to the points. But what I can do, if, for instance, I didn't want size to be related to height, I could just say, let's have a fixed size to my point, and I can put that outside the aesthetic command, the AES call, but we can still have it inside _point, and that's going to make all the points size 2. That might actually be the default size because this looks pretty familiar to us. I invite you to go around and play with different sizes and see that by changing this number, you'll get all the points being the same size. So we're not mapping an aesthetic to the points, we're mapping something across all points. This is something that's applied universally to all the points if it's not inside an AES command, inside gm_point. And if we instead wanted the size of the points to be still related to height, but we wanted all the points to be colored a different color, not be mapped by gender, we could put the color command outside the AES call here inside gm_point. And so we would get all the points being purple, even though they're all different sizes now, still based on height. So again, just want to point out that we can control things about our glyphs without having them be aesthetics. They can be something that's fixed throughout the entire plot. So that's what we've got about part 1 of slideshow 1 from chapter 3. And I look forward to talking about all this in class, working some additional examples very soon.